all the speakers of the workshop connected?
Let me check. I guess so. Yeah.
Okay.
Yep.
So I think we have to make the speakers presenters. So I kindly ask all the speakers of the workshop to raise their hand so we can easily identify them.
And I just wait for you, Guido, no, to get started.
Yes, I was looking for Carlo Cafasso, okay. Let me make him presenter.
Mm-hmm.
Hi, Guido, is Carlo. I don't know if you can see my name on the right.
Yeah, Carlo, you are already presenter.
Okay, thank you.
You can lower your hand. Pasquale, okay.
Hi all, I'm here.
And Danilo.
And Danilo. Yeah.
Okay, I think we are all set.
Cool.
So thank you again to all the attendees to join back this session. We are going to present the first workshop of DRCN 2021. So I would give the podium to Marcello Forti from ADVA, who will chair this workshop. So Marcello, please.
Thank you, Guido. I will jump on this virtual podium. So, and well, let me first of all give you again a big thank you. I mean, thank you first of all to the Politecnico di Milano, which has given the opportunity to us as a community to organize an industrial workshop like this. I was also, I'm going to say thanks in advance to all the contributors, so to all the speakers you will be listening, and also people behind the speakers that put, let's say, the content together. And I personally very happy about the results that of this workshop, what I'm seeing in terms of content, because we first of all, we are addressing a very important topic that we are touching basically every day, which is, you know, what transition, where this transition is heading us to. And it's going to be seen from different angles, from different point of view, maybe a technology point of view, where virtualization is the key point, but virtualization will be definitely seen as a driver to move the business of a generic enterprise company, which means also a driver for a carrier today in the telecommunication network changing and migrating their product offering. Just for you to know, all the attendees at this workshop will be registered. So there will be definitely a video you can access to and see basically or re-see the workshop itself. We also, with Davide Botto, who is co-chairing with me this workshop, decided to organize it in a structure of 20-minute slots each. So it's going to be quite tight, and so we would ask you just to use the chat to raise any questions, and me and Davide will collect them and have a dedicated Q&A session at the end of the workshop, which is scheduled at 4:30. But if we will have time from time to time to ask the one or the other speaker, because maybe it's faster than scheduled to answer to the one or the other question, we will be doing this. Okay, so just as a guideline, okay, how to manage the time. Now, let me first holistically, I mean, I prefer to try to describe in a very few minutes the content of this workshop rather than through an agenda. Let's say to show the agenda in a different way. As I said, we want to present to the audience the impact of the technology of virtualization from a main plain, let's say, technology point of view, where we're going to start looking and talking about the virtualization in the 5G and IoT space. We will be touching two main topics: the ultra reliable low latency communication. Okay, and this is actually going to be done showing concrete examples that we have already out of the industry, especially really the industry, the factory, the logistic, to make it somehow tangible, what has been already done and what could be done with this. And the second topic is about the migrating this, let's say, 5G networks toward the open models. ORAN is one of the major known examples, but also we want to basically tell you what it takes to bring these models from, I would say, theory into true reality. What are the challenges ahead? And I like to thank my colleagues, Anthony McGee, who is basically the Senior Director of Business Development at ADVA, the company I work for, to taking care of this. Afterwards, we want to make, I would say, jump into a very, I would say, different point of view of looking at virtualization. And we're looking more at the skill set point of view, because we are talking about migrating, so moving from one model into the next one. This means that we need competence, able to master the previous, I would say, the legacy model, and all the necessary activities to move into this open, virtualized, new, I would say, model. Sorry to repeat myself. And we have been collaborating with the Politecnico di Milano together with a system integrator like iWay, and stress, say, taking a picture of where we are today and what it needs to take and to learn to support the model tomorrow. And as I said, it's going to be a presentation done jointly from Politecnico di Milano and iWay. I make you just an example. I was mentioning before about the Open RAN. Open RAN, it means that you need to define clear interfaces between different modules with tearing subsystem apart, and then we put them again all together. And you can imagine in this building block, I would say, examples with all these software components, the level of competence and the level of efforts, also integration effort, this is needed. And I thanks in advance Professor Meyer, Davide Botto, who is the CEO of iWay, but also two students from Politecnico di Milano, Giulia Nava and Fabio Carminati, who are there going to witness basically what has been already done within the academic context. And also Davide will show in anticipation his own iWay experience to meet and address those challenges. In order not to be too theoretic, we decided also to insert before the coffee break a 20 minutes live lab exercise. So it's going to be iWay, Pasquale Magliacano, sales engineer at iWay, which is going to drive us through a true, I would say, examples how a virtualization technology implemented as a universal CPE application, which is a core part of this workshop, could be used, could be deployed with true and real-time systems. And I think this is something that can help us to get, again, another perspective to the virtualization topic. And this, as I said, is going to be just the last session before a coffee break. And once the universal CPE topic is going to be introduced in such a, I would say, pragmatic way, we will leave the floor to Colt and to this contribution talking about enterprise transformation, but specifically to how Colt has changed his product offering based on universal CPE to allow and to enable, also, the edge of the network and to offer, I would say, virtualization-based services to reduce both the time to market, because virtualization software means also a major flexibility and a shorter time to market, and basically to make also the management of a network easier. And talking about, it is actually the Colt presentation. And to conclude, we want also to touch a little bit the aspect of managing the network, managing a virtualized network, or using virtualization and software to manage differently a network. And we talk about two slightly different types of networks. The first is a critical, as a mission critical network, which is going to be described by ATM, by Carlo Cafasso, and which is head of operation and maintenance telecommunication at ATM. And last, finally, is going to be Danilo Noschese from Open Fiber, who's going to stress the zero-touch provisioning aspect to orchestrate and activate the services on their quite, I would say, famous and cutting-edge, I would say, project in Italy called Open Fiber. So that said, in a very shortly, I mean, I hope I can bring over, I would say, the different aspects we are going to touch into this very interesting workshop. And I would leave the floor to the first speaker, who is Anthony McGee from ADVA. And I would say thanks. My name, as Guido was mentioned, is Marcello Forti, and I'm heading all the activities of ADVA here in Italy. Thank you.
Thank you very much, Marcello. Before proceeding, just a technical remark. Please, the presenters should not admit attendees from the lobby, because there are the volunteers that are taking care of that. Thank you.
Thank you. All right. So I will leave it.
Thank you, Marcello. So I just need to figure out how best to share my screen. Normally I can see it. Oh, there we are. I can see that. 2 seconds. Right. Okay. Marcello, can you just confirm that you can see my screen coming up?
Yeah, I do.
Brilliant. Okay. Thank you. Okay, so it's a pleasure to be here in this tutorial. Thanks for having me along. And so I'm going to be kicking things off, proceedings off, and talking about the convergence of 5G and enterprise. And obviously, we want to have in mind the reliability aspects of that. So in terms of an agenda, I'll set out to describe what we mean by the convergence of enterprise and wireless. So we'll talk about enterprise virtualization and private 4G and 5G networks, how those things are coming together. We'll also talk about the network and operational requirements, and I'll provide some use cases that will take us into different requirements of that network. And then finally, we'll take a look at how the open interoperable standardization process is addressing those requirements. And we'll go through some of the good things, some of the not so good things, and also how we would encourage people to improve matters. So before I set out, let me just take a step back, look at virtualization. What do we mean by enterprise? And this is just one example. So what we've selected as an example is a store in a box. And as an example, commercial outlet. In those facilities, they may have a range of different devices, physical aspects that they deploy in the course of running their business, including security cameras, online catalogs, point of sales terminals, connectivity within the facility. And there is a trend within the industry towards virtualization of some of those platforms and running those virtualization platforms on top of edge compute. And it could be a wide range of functions that need to be deployed. And this is what we mean by convergence of the enterprise onto typically white box edge compute facilities coming from a range of compute vendors. And one of the very small plugs in this presentation from Advert is that our place in the industry in the network here is the use of an NFVI layer to host those virtual networking functions and indeed containers on top of the compute platforms. If we look at wireless and look at 5G as an example, what we see here is that there are three predominant use cases that pretty much everybody in the industry talks about. One is the public network, improving the speed that the handset the user gets on their handset, typically people using that for better user experience. There is a big use case around private wireless, so building networks on campuses for industry. And this is where I think latency and reliability really comes in. And then following that, it's kind of the sensor networks, wireless, Internet of Things, all of those things. And what I would be fair to say is that this 5G network is increasingly looking like it's going to be built on a very open architecture. Marcello mentioned ORAN, and we think that's going to be a multi-vendor network that is bringing this to fruition. So if I take a look at the evolution of 4G and how that's moving towards 5G, we talk about the use of public and private networks. There are some three kind of fundamental parts that really leap out around performance and reliability. And the first one of these is, as well as giving faster speed to the user and better scale, etc., one of the real things that people are trying to build out of this 5G network in their premises is a lower latency service, so achieving ultra reliable and low latency communications. And obviously reliability comes into that. So it's really a performance objective, not just to give people a better user experience on the handset. And the other thing that comes out of the discussion is, in order to give people better throughput to their network, the 5G standards have been written around the adoption of increased spectrum, or let's say higher frequency bands in the spectrum, in order to deliver the throughput required to the handsets and the machines that are going to be using this. And that adoption of higher frequency, we believe, is going to lead to a bit of a challenge when you take the networks indoors. So the first thing I'm trying to say here on 5G is that this network is anticipated to be a precision, high-performing 5G. It's going to be deployed nearer to the end user, and it's going to be deployed inside of buildings. Now, many people looking at in-building networks are looking at how do you build this network for the private facility that wants this precision, high-performing 5G network, at the same time as making that network available for use in a public licensed network operator scenario. So this is an example on the screen here is an example of a JOTS. In the UK, we have joint operator technical specification for in-building neutral hosts. And what this tries to explain is that there are many reasons why you might build a network in a customer premise on a campus. One of those is to give the users on that building access to their mobile network. The other function may that you just want better wireless coverage. Some people may go for a low-cost Wi-Fi solution, but somewhere in the middle, there are going to be people wanting this wireless network to be built to boost their industry, their adoption of technology within the industry. And this is where that middle ground is, that private 5G, also being a neutral host network, is going to really come together. And this is where we think this high precision 5G network is going to be used. In terms of 5G and how this is starting to look like it's going to be built, in the wide area macrocell network, It's being deployed very much as we saw 4G being deployed, but for the private network, we're seeing quite an adoption of cloud-based architectures. We're seeing an adoption of all-RAN, so the separation of the baseband unit and the radio network into its various components, principally being the DU and the CU. And obviously, if you're going to take all of those components that have now been decomposed into their various functions required at various parts of the network, there are some things that you have to consider when you pull that back together. And the first thing is, if I'm building this facility into an enterprise, then I have my existing enterprise use case. I've got my firewalls, my SD-WAN functions, in addition to the mobile network to be hosted. If I'm building a public network, however, I have to make sure that the components are approved by the mobile operator. The service needs to be approved. And there's this middle ground where I'm building both a private and a public neutral host. And the idea here is that you're actually converging the enterprise space, the private network space, and the neutral host space into one combined service platform to give a better business case. But also that network is now delivering different types of service to different types of users, a premium service for those willing to pay for it or that are building this network, and then a best effort. So we'll get onto the topic of network slicing as we see this kind of network being deployed. So with all of that, hopefully made the introduction clear. Now I'd like to just spend a little bit of time on some example use cases. The first one is a use case that's very close to my heart given current activities, and that is around logistics, tracking of goods, around networks, and principally what we're seeing here as a big driver is the use of this kind of technology in ports. So as goods come into countries, need to be moved around the country to be processed, the idea of a free port is becoming obvious in some places where the goods need to come in, be processed and tracked as they move around these geographies. Now, a lot of people are talking about use of drones and 5G, and in exactly the same way, we've seen that kind of adoption in this project that I'm talking about, where we're seeing drones that are being used to fly around the port. They're using a 5G network to be able to control the drone in a control loop. We're seeing the tracking of sensors as they get loaded onto lorries, and we're seeing the tracking of those lorries as they get driven through a network. Now, what this requires is a very precise location tracking facility within the network. It has to be low latency, or otherwise the drone control loop won't work correctly. And the other thing is that it has to be secure. You don't want somebody getting into this network and tweaking the control loop and finding that the drones crash out of the sky. That just is a non-starter. So this is a great example of what we would have previously called machine type communications, not a handset inside, it's all machines talking to the network. Another use case that Adva ourselves are considering deploying is the use of a 5G wireless network in a manufacturing environment. So Adva is currently in the process of building an optical assembly platform in Germany. And the idea here is that we're exploring 5G to explore how do you build that facility in a way that does not require lots of cables to provision the manufacturing facility. We talk about cutting the cord and using this network to deliver an automated precision platform on which you can assemble very accurately very small components. And with the use of 5G comes the need to control sensors and actuators, monitor the network and control the actuators with very low latency. And it also opens up the need for a time-sensitive networking. Another use case, and this is where I think reliability really comes in, is the adoption of a 5G network to build a campus that is actually supporting emergency services networks. An example of this could be a transport hub. In this case, I've selected as an example an underground train station where there are a number of small cells dotted around the platforms and at different levels of the station. And the idea is that all of these small cells have to be accessible to fire brigades, ambulance, police, and they have to remain accessible even if a centralized core that's being used to run that network for business case reasons fails. So if there was somebody digging the road up at the time when there is an emergency services requirement, the command and control facilities in this network are going to require this network to remain operational. Now, even though you may still use a centralized core for 90% of the users, you really want the ability to steer some of the traffic into a locally hosted evolved packet core involving all aspects of the ORAN chain, DU, CU, user plane functions. And what this really drives to a requirement is I need a way of offering myself a resilient network that allows me to steer traffic to a usable core network, whether it be centralized or locally hosted, and that has to be a reliable network as well. Now, if we look at how people are deploying these in a kind of open standardization environment and look at how some of those requirements are being addressed, one of the obvious standardization processes is to look at ORAN. So ORAN's architecture defines all of those radio functions that are used in a 5G and indeed a 4G network, including the radio unit, the distributed unit, the RIC, etc. And it's defining the interfaces that connect those together, F1, E1, all1 as an example. And it's really starting to mature in terms of how do you accelerate the hardware that's being used to run the network? How do you synchronize all of these components? There's a lot of distance being, a lot of ground being covered. So synchronization is starting to be adopted, lots of forward error correction being taken into hardware to speed this and make it more resilient. There are some gaps, however, and that relates to resilience of the network, to the time-sensitive nature that we described in the previous slides. There is a gap, in my opinion, when it comes to location services and also driving towards those lower latencies. So I just wanted to spend a little bit of time talking about what we think can be done to try and improve on that. One of those things is to explore the use of phase alignment at almost every part of that service chain, including the radio units with precision timestamping on those, the DU with precision timestamping as well. We believe there's a need to measure the delays across the front haul network very accurately using those tools. And the other thing is, if you're going to be doing mechanisms to track the use of machines around a network, there are a whole plethora of things that you can do to achieve that. One of which I would describe as measuring the time of arrival on the different radios that are forming the network. So this time of arrival is one of the key drivers as to why you need to synchronize all aspects of the network. And you need to do that in a very precise way, whereas the baseband unit would have previously required 1.5 microseconds for 4G. We're seeing a need for these radio units that are now separated and diversely connected down to 65 nanoseconds, which is a really tight requirement. The other thing I mentioned in my slides was time-sensitive networking. And what we see here is 3GPP are standardizing on the use of TSN in order to deliver time-sensitive networking across the network as a service. A lot of people have looked at TSN for delivering a very reliable front haul network. But what I'm talking about here is the use of time-sensitive networking over the top of the 5G network itself. And this requires a TSN time translator device to sit at both the user plane function and ingesting express traffic. And at the device side, it needs a device side TSN translator in order to deliver that as it egresses the network in a predictable manner with bounded latency and with prioritized delivery of high priority services. The other thing I'd like to cover is resilience. So if you intend to be able to put DU resources into maintenance modes of operation, clearly there's a need to be able to re-establish the relationship between a radio unit and a DU platform. And here we think that there is a case for having transport switching capability that is programmable, but also that can respond to changes within the network as those things happen. Finally, if all else fails, at some point you're going to have to go out and restore connectivity. So in the case of a fiber break, something that's really a key part of this reliability network is to be able to detect where physical layers may be broken, send a team out to go and fix those with minimal time and minimal delay, and achieve a restoration of the service. And for that reason, even physical monitoring of your fiber assets, we think, is a really key requirement. So I'd like to summarize what I've kicked off, hopefully to tee the rest of the sections up, is that we believe that there will be a need for convergence of 5G and the enterprise, being campuses, shops, facilities, manufacturing plants, train stations and the like. And here we believe that time sensitive location tracking and low latency is required. And the way to deliver that is by very accurate adoption of synchronization. We believe that there is a need for hosting of the core network very close to the user, and also the ability to slice the network in different ways. In order to achieve resilience, we believe that there is a need for programming the relationship between radio resources and DU resources, so use of transport devices to achieve that relationship. And then, as I said, if all else fails, the need for restoration, so the ability to very quickly detect where physical layers have broken, measure the distance to the fault, send a team out to go and fix those. So fiber monitoring and fast detection of those faults is of paramount importance. And with that, I'd like to thank you for the opportunity to speak today and hand the floor back to Marcello.
Thank you, Anthony. Very, very interesting indeed. And okay, so as I said, any question, please, via chat so far. And I would then pass the microphone to Guido to start his speaking slot about the challenge of today's skill for the technological challenges of tomorrow. Please, Guido.
Thank you very much. I hope you can see the slides shared. Thank you very much, Marcello, for the introduction. I would like to present the activity that Marcello already mentioned of cooperation between Politecnico di Milano, ADVA, and IWay on the topic of NFV. But before, I would like also to explain why this activity is very important for the development of this technology. So basically, today we are witnessing a dramatic change in the way the networks are operated and also engineered and designed, that is needed basically to face the exponential growth of traffic and all the functionalities that are being added with 5G technology and all what is around that. That requires networks to become smarter and also cheaper in a great sense. This is basically done by integrating in a tight way, much tighter than in the previous time, the IT with the telecom. So the ICT is a great opportunity. It was started many years ago already with the cloud computing, which is, let's say, the forerunner of this new trend, with the large centralized data centers. But then with the introduction of software-defined networking, in which networks can be controlled by software applications, and then on network function virtualization, that is basically the possibility of implementing network equipment as software applications, then this transition has been continued and made more effective. Lately, we have also the distributed cloud computing capability, the new paradigm by which computing capacity can be also placed in sites that are closer to the user, the so-called edge and fog computing, which allows especially network providers and service providers to push some added value of the internet closer to users and let's say to face the price competition with the over-the-tops. And this is of course favored by 5G, as Anthony has already mentioned before. So the combination of these three elements, software SDN, NFV, and cloud computing allows the perfect integration of the control on network and computing resources to develop the vertical applications. So this is a new opportunity. However, in order to convert this new trend, which is technological mainly, into new business opportunities, we need substantial efforts. All the major players in this scenario, equipment vendors, network operators, service providers, system integrators, are playing together in order to create an ecosystem. And in this ecosystem, of course, it's very important also to spread the know-how and promote the training, especially for the future professional specialists. And this is where, of course, a university as the teaching institutions come into play. So in order to transform all these new knowledge into the courses that are preparing the students, we have set up a cooperation between Politecnico di Milano, ADVA, and IWay. Especially, there is a program in Politecnico di Milano which is called Passion in Action, and then more specifically in our department, the DABE, which is called People at DABE, which is, this program is dedicated to promote the integration between the Politecnico, the university, and the companies in teaching. So in this scenario, we put up to this cooperation, which is basically based on the three pillars: one hardware and software manufacturer, ADVA, one engineering company and system integrator, IWay, and the university, Politecnico. And this led us to organize a course in the last year. So the course is called Smart Networks and Service Orchestration. It was basically given in April of last year, and it focused mainly on SDN and network function virtualization, just focusing on the lab experience, so providing the students the possibility of not only learning theory, but also practice with a practical lab. So the lab equipment was fully provided by ADVA, and IWay participated in setting it up on Polytechnical facilities. And then this allowed the students to perform these final projects in this course. And it was also supported by the European project Metro Hall. So this is a scheme of the lab. You can see here on the right side the place where the facilities hosted the physical lab. And since at that time there was the COVID, in any case, we could all the same keep the course, because basically the connection of students and professors could be on a remote basis. And so the experience was very similar to what can happen when you are inside the lab. Even if people were far away due to the COVID, in any case, we could experience, we could enjoy the full experience. So the lab was organized in actually two overlapping facilities in the same rack, hosted in the same racks, an SDN side and an NFV side, both based on ADVA controller and orchestrator. And here you can see the rack with also the optical part that was based, it was mainly part of the SDN. And maybe you can also hear the sound of the heating, the sinks in order to sink away the heating. And we had 21 participants, very successful as a course, and at the end we had various teams working on projects far beyond their assignments. So this year, actually, the cooperation continued on. Instead of this smart networking course, we moved the lab into a switching and routing course, which is a 5-credit regular course inside the Master of Science in Telecommunication Engineering. And next year, this course will change the name into Network Automation. Of course, we will maintain the cooperation with ADVA, and this will allow us to further update programs in the sense of teaching new networking technologies. So now I would like to leave the mic to Fabio Carminati and Giulia Nava. Fabio Carminati and Giulia Nava were students in the Smart Networks course, and Fabio Carminati will tell something about the final projects that they implemented. Giulia Nava instead will also tell something about the master thesis project that she was able to perform exploiting the same lab. So she will graduate at the end of the month with a very successful thesis, thanks to the possibility of exploiting the lab of the course and also the expertise that she learned during the course. Fabio, I think you can take the mic. Are you there?
Yes, I'm here.
Okay, so I switch the slide and I give the mic to you.
Thank you, Professor Meyer. The purpose of this project was to create and monitor the alarms coming from several terminals. For this reason, we developed a software-defined networking alarm notifier, a multi-thread application that retrieve alarms coming from the various terminals devices using netconf. We based our model on the SDN optical lab previously described by Professor Meyer, and we consider 3 devices. Here we can see the architecture. There are the terminals that might generate the alarms. We have that for each terminal, there is a thread up and running that catches the alarms and stores them into a DB. This DB is an abstracted entity. This allows the interchangeability of databases technologies such as SQL or NoSQL. For example, it is also possible to use MongoDB. There is also another important entity that is the notification manager. The notification manager is responsible of notifying the users about the alarms coming from the SDN devices. Inside this notification manager, there is a thread that every second queries the database to check whether new alarms have been discovered and stored into these databases. There are different levels of severity for the various alarms, and only those that are greater or equal than a user-defined threshold are notified to the user. There are 2 possibilities by which the alarms are notified to the users, either email or through Telegram. We can move to the next slide. Okay. The first one is the email. Here we can see that the alarms are organized in elements with the description about the device IP, the severity alarms, both with a numerical value and also with a verbose description. Also, the time is another important information that is shown and sent with the email. The second type of notification element is through Telegram. It is possible to query a Telegram bot that we design in order to obtain some information about the alarms, such as the cumulative alarms that occurred in the considered network up to that time, or we can also list the alarms according to the specific device considered. Another important aspect is the definition of a graphical user interface. with this graphical user interface, it is possible to interact with our project in two different moments. Either before the analysis starts, with the possibility to edit the notification parameters, such as the email address or the information about the Telegram for the Telegram bot notification. And also it is possible to add the features, the characteristics, and the number of devices that must be taken into account during the evaluation of this alarm notification manager. The second aspect of this GUI is the capability to analyze the results during the analysis. Indeed, here we can see a possible graphical representation about the alarms organized according to their specific device that has generated them. There are also at least 3 possible graphs that we develop. In this reason, it is also possible to refresh this graph during the simulation. The refresh will query the database in order to check and to update the information that will then be plotted. It is also possible to save, not just to look at this graph, but also to save them for a post-evaluation, for a post-analysis, in order to be able to evaluate these results. And I think that for this project, that's all. I want to say thank you to my colleagues, Andres and Emanuele, with which we developed this project. Now I will leave the word to my colleague, Giulia.
Okay, thank you very much, Fabio. Giulia?
Yes, I'm here. I'm Giulia Nava. Last year I attended the Smart Networks and Service Orchestration course, and together with some of my colleagues, I implemented one of the projects regarding the network function virtualization part of the lab. The NFV activities were focused on the service deployment and orchestration procedure with the use of the Ensemble software suite for the design of the network services. Therefore, it was used for the definition of the service chains, the VNF composition, interconnection, and the resource allocation. And then it was also used for the deployment of such network services on the selected compute node. This was achieved through the creation of the connector applications and the launch of the zero-touch provisioning cycle through the Ensemble director. The Ensemble orchestrator was used for the definition of the network service template and for defining all the VNF-related parameters. Then, after the deployment of the service chain, it was also used to perform the management tasks related to the VNF and the network service lifecycle. For example, to reboot, terminate, or scale the installed instances. Part of the project was dedicated also to the configuration of the installed virtual machines. In particular, the VNF were installed as virtual machines, and they had to be configured in order to allow the exchange of traffic and also to perform the required network function. For example, my group had to implement a linear chain with a virtual router and a virtual firewall, and then CentOS VM were used to generate the test traffic and verify the successful implementation. The project was based on 4 main phases, which were the design, deployment, operation, and maintenance phase. During the maintenance phase, for example, it was possible to detect eventually some failures or to change the running service with the termination, scaling, or upgrade of the virtual network function installed. In addition to the participation to the course, I also had the opportunity of using the ADVA lab for the purpose of the thesis. My thesis work focuses on a characterization of the VNF behavior with the analysis of the relation among the resource allocation, traffic features, and the service performance. It also aims to find some models to predict such behavior. For the thesis scope, the ADVA testbed was particularly useful because it was exploited for the deployment of the service chains with the possibility of defining a great variety of topologies and virtual network function compositions. And this allowed the possibility of comparing the results obtained in a great variety of scenarios. These service chains were also deployed with a quick, automated and error-free process thanks to the use of the ensemble connector, director, and orchestrator. On the running service, it was also possible to perform some orchestration-related operations, like, for example, the resource scaling, which was particularly relevant for the purpose of the analysis of the benefits of different resource allocations. One of the contributions of the thesis is also in the development of some tools for the monitoring and profiling of the virtual network functions under test. And these tools were installed on the instantiated virtual machines and used to monitor the VNF, to profile them, and also to collect a great variety of measurements later used for the consideration of the thesis. These samples were collected regarding both the VNF performances and also some resource-related parameters. Lastly, thanks to the use of the ensemble connector, it was possible to achieve a high quality of service by the virtualization layer, which limited the impact of the collocation of multiple VNF and led to the opportunity of providing analysis in depth of the virtual network functions. For example, a service chain deployed for the purpose of the thesis is illustrated in this slide. The two CentOS VM are used as service endpoint for the generation and the reception of the traffic, and then the traffic is steered through the actual service chain, which can be composed either of one single VNF for the standalone scenario or of multiple VNF with different topologies. Then the outcome is a characterization of the VNF performance and resource consumption as a function of the input data rate. The same test can be replicated in different scenarios with different VNF composition, different interconnection, resource allocation, and even with different traffic features which can be configured by the user. So starting from the samples collected, it is possible to provide an analysis of the impact of different configurations, and also the models are retrieved. So to conclude, the course and the hands-on activity on this aspect have been a great opportunity to understand the different components of the NFV framework and how they interact with each other, and also to develop all the skills that are necessary to operate on a NFV environment. Then in my case, the use of some measurements which are retrieved from a commercial NFV system has been particularly useful then to elaborate all the consideration that I made in my master thesis. Thank you.
Okay, thank you very much, and Giulia, and also Fabio. And so I stop my presentation, and I leave the podium to Davide Botto.
Thank you, Guido, Giulia, and Fabio for your presentation. I will try to be quite quick. So we have worked on NFV and SDN for some year, and so we have lived for these years the thoughts, the concerns of our customers for the impact of these new technologies in their companies. We are talking about a challenge, just as it is needed to enable organization to leverage the power of the infrastructures and to provide in such a way multiple business and operation benefits. So we have to talk about a challenge. Just as SDN and NFV are perceived as critical, as a very fulfilled of critical aspects to meeting these targets. So when we talk about NFV and SDN, we have to talk about technical operational and organizational aspects, and we have to define clearly where we have to start from. If we talk about the technical aspects, first of all, we have to ensure that the performance is able to guarantee security in a carrier-grade environment. Just as we have to manage complex solution and environments in this case, and we have to be able to integrate in an end-to-end way the services, thus guaranteeing the interoperability between virtual and physical solution, just as obviously we are talking in this moment of a period in which we have the coexistence of these two environments. From the operational point of view, on the other side, we have to work on the life cycle service management and procurement, just as these two aspects are really important from the operational point of view. When we talk about the management and orchestration process, we have to create this process from the beginning, and this is another key for building a virtualized networking environment. Another point is the end-to-end performance. That is really important, just as we have to adapt operation maintenance process. We have to transform the OSS, being able in such a way to manage the virtualized function. And to make a summary, we have to have in our mind that we have to go hybrid. Just as I was saying before, for a certain period, we will have the coexistence of physical functions and virtualized functions. And so it's a must being able to manage the coexistence of these two. But from the organizational point of view, in our experience, we faced the most challenging aspect, just as this is a cultural aspect that is to be that has to change. Namely, we have to schedule and manage the fusion of network and IT areas. This is a very important point as we have lived in these years in our customers' environments. We have to deploy new skill sets, and we have to deploy new models too, changing the culture inside of the network environment teams. So if we try to plan what is to be done, we have to create several steps. Just as, and particularly, there is no fixed solution for everyone. Every customer, every network needs to be approached in a very different way, and so it is to be sized and tailored on the network and IT of the customer. First of all, it's important to understand that NFV and SDN is a top strategic priority for the company, for the whole company. It's not only something that can impact one team, one department, and not to be really the idea of changing completely the company. And this point is not to be underestimated. It's important to create a business plan, a very detailed business plan that must consider benefit and cost, and being able to evaluate operational, organizational and technological aspects that may contribute to the success or fail of the design and the project. And then particularly, it's important to prepare all the employee for the change. And this is done by making a serious assessment of all the people in the IT and networking team, but not only on the technical, but as we will see, also on the procurement, also on many other teams that need to be aware of the big change that is ongoing. Another point, as I was saying, is to engage the whole company. And this is the right way to be able to get all the benefits for this of this step. The ecosystem should be built in such a way to be able to acquire all the necessary skill. And so the ecosystem of all the teams and all the department is really important to be set up. Another very important point is not to think globally, but to start at the beginning with a slogan in mind that is start small, namely start with the small part of the network that should be virtualized. Just as this is a gradual immigration, it's gradual to think of the people that will learn. It's gradual to think about all the know-how that requires time to be spread all over the company. It's not so quick in a real environment for all the teams and all the people to be really aware and fully motivated in this big change that the company is working on. And the back office too is to be really strong and well organized. Just as it's really important to understand that this hybrid environment will run for several years. So even the back office need to be able to manage all the process and operating models in a hybrid way for several years. What prevents operators from implementing such an ambitious but necessary plan? Obviously, it's the existing culture that typically is existent inside of a company, namely not all the network teams are ready or are willing to relinquish the control to IT. But if the silos between the IT and the networking department will not go down and collapse, it will be really difficult to think of a real change. We think that this is one of the biggest obstacles that a company typically face with. So it's really important to work on the culture, work on the competence, and think of these two areas that typically are distinguished at each other, but to collapse in only one team. So from our observatory on the Italian market, but speaking with foreign colleagues, the situation is not very different. We register a lack of skills in the market. So this may be one of the reasons for which the companies typically are so slow in adopting these new technologies. But we think that only with the contribution of the university, we succeed in covering this gap, training new engineers that will have a background both on IT and networking in such a way to be really able to sustain this new challenge. And obviously, I'm really grateful to Politecnico di Milano and Professor Myers for this opportunity, just as I think that this was, and this is currently, a very great occasion to work towards this direction. Thank you all, and I leave the word to Guido.
And back to me.
Back to you, Marcello.
Thank you, Davide. So as we basically saw, it is a long journey. We are at the beginning of a long journey. Anthony described, let me say, the target where we are heading to. Guido and Davide are basically witnessing that we are doing the very first steps in the public-private partnership also, which is really good. So now I think we want to take you along, and that's the last slot before the coffee break, just to touch, as I was anticipating, touch really with the virtual hands the system. So as we're gaining experience, we want to at least share a little bit of real life experience. And I would ask Pasquale Magliacano from Highway to take the lead now and guide us through this very interesting demo and presentation.
Thank you very much, Marcello, for your introduction. I will update my presentation. I'm Pasquale Magliacano, and I'm the network coordinator in Highway. Today, just before starting with the live demo, I will spend just a few slides to enable a better understanding of the live overview. As we understand from people speaking before me, we have clearly seen that a new kind of network engineer is burning. a network engineer that is more or less an hybrid creature, and that will have to make coexist the legacy network engineers skills with the visionary approach of cloud evangelists and the ability to speak the same languages of IT sysadmin and software developer. Of course, the creation of this new profile must begin with the university, with the preparation of new training curricula that will train the students. But I think that the only way to get the target is to establish a good synergy and cooperation between the main actors that have a key role in defining the new landscape of telecommunication world. These key actors are, of course, university, technology vendors, service providers, and system integrators. A good example of this kind of cooperation, in my opinion, is the one we realized with Highway, with Professor Meyer from Polyme and with engineers of ADVA in preparing the network function virtualization course, the new network function virtualization course of Polyme. In particular, me and my colleagues with ADVA prepared the entire setup of the new network function virtualization laboratory. This NFV lab will be the basement for this live overview. So just a brief description. As you can see, the main hardware components of the lab were the NFVI hardware POPs based on standard COTS server. In this case, they are Lanner NCA 2510. The manual hardware infrastructure is based on HP ProLiant server, and one emulation connection is realized through a layer 3 Cisco Nexus switch. The software components for the network function virtualization are based on the ADVA Ensemble platform and are the Ensemble orchestrator responsible for the network function, for the virtual network function onboarding and lifecycle management and service orchestration, the Ensemble director responsible for the network management, and the Ensemble connector that is the software hosting platform for the new VNFs. Here you can see some more details. In particular, we can understand that the hypervisor platform was based on VMware vSphere E6i. We can see that also an SDN backend controller is part of the architecture. We realized the IPsec management connection towards the connector using a pfSense firewall virtual machine. And we created 3 Ubuntu virtual machines just to start the zero-touch provisioning authentication process. In Ensemble environment, zero-touch provisioning is a way to automate the instantiation of new connectors and new service chains. For those of you then that are deeply interested in the technical details, here you can see the ETSI NFV framework, and you can understand how the Ensemble platform maps on this ETSI framework. In particular, we can see that the Ensemble connector is the operating system running the network function virtualization infrastructure and hosting the new VNFs. The Ensemble controller covers the role of the SDN controller. The virtualization director is responsible for the network management, and the Ensemble orchestrator is responsible for virtual network function management and service chain orchestration. The whole infrastructure is based on an OpenStack cloud core. During this short live demo, we will have a look to the anatomy of a live service chain. We will speak about VNF onboarding and automation, network service templates and application. we will see how to which are the steps of a zero-touch provisioning procedure, and we will have a look to some troubleshooting tools. Okay, so now we are ready to have a look to the live environment. Okay, first of all, let's begin having a look to the orchestrator graphical user interface. Okay, as you can see here, we can immediately understand that there are two running services. These two services are running on the two tenants that are available on the system at the moment. So this is a multi-tenancy architecture. And for each of these running service chain, we can operate some activities, like, for example, terminate or restart the network service. We can edit a live service chain. Of course, it is not a recommended practice, but we can. We can have a look to the network diagram of a live service chain. You can easily understand that in this case, for example, we have three virtual network functions, a microtic router and two CentOS machines, and we have four virtual networks defined by the students. Two of them are used to interconnect the virtual network function, and the other two are used to connect the live service chain to the external networks. For example, the WAN and the LAN in these cases. Going a look to the raw details menu, we can have a more detailed view of the service chain. In particular, we can see all the VNFs that are inserted in the service chain. We can have a look to the optimization flavor associated with them. So we can see the association in terms of RAM, disk space, CPUs. We can see which are the networks involved, and we can see which are the links defined between the virtual networks and the virtual network functions. We have also some useful tools. I think the most important of these is, for example, the possibility to launch a VNC console. In this case, we are connecting, for example, to the microtic router, and we can have a look to all the networks that are managed by HIT. We can, in the same way, have a look to one of the two CentOS machines. And okay, we can easily see the network configuration of the machine. We can see that it is using the microtic router as the default router. And of course, because this is a live service chain, we can check the internal service chain network connectivity, and we can see that it works. And we can also have a look, for example, to external internet connectivity, for example, launching a trace path to the Google DNS. And as you can see, we have also the connection to internet via a fast web router. Okay. Now that we have clear in mind which are the elements that are composing our service chain, we can try to understand which are the steps to configure and orchestrate a new service chain. First of all, you have to onboard all the VNF you need to create your service chain. What does it mean to onboard a new VNF? It means to upload an image, and in the same way to define which optimization flavor you want to associate to this virtual network function. An optimization flavor, as I already told, is an association in terms of resources like disk, like RAM, like PCU. And VNF onboarding is also a way to automate the configuration of this virtual machine. And you can automate the configuration passing configuration parameters through some standard techniques, like, for example, using config drive, or, for example, using cloud config. You can use SSH scripts. You can define A availability profiles, giving so resiliency and redundancy to your VNF. You can define scale profiles, defining the reactivity that your VNF must have. You can integrate some VNF manager of third party in case you don't want to use the Ensemble one. Once that you have onboarded all the VNF you need to create your service chain, the second step is to define a network service template. A network service template is really similar to a live service chain, but it is an offline architecture. And so you can reuse this network service template to instantiate all the new edge points that you want. And so you can reuse it for all the service chains, for all the similar service chains that you want to instantiate. As you can see here, you have the same graphical topology of the network service. You can see the virtual network functions involved in the service template. You can see the virtual networks, and you can see the links between the virtual networks and the virtual network functions. Now you have created your network service template, and you are ready to go on the director. That as I already said, is the network management tool. Okay, let's log in. Okay, this is the main dashboard where you have a summary of the topology of the network. You have the summary of the alarms, of the sessions, and the connectors configured. From here, you can import your configuration templates, in particular the network service template we already defined, and you can even create or import some other configuration template that are used to define the configuration of the connector. These are called zero-touch template. Once that you have template for network service and template for connector, you can merge them and create the so-called application. An application is a complete configuration of service chains and connectors that can be applied to all the new connectors that you define. So at this point, you can go on the inventory of the director and create your new connector. You just have to assign an host name, a management IP address, an authentication code that will be used by your installation technician to go on site and to start the zero-touch provisioning procedure, which is mainly structured on 5 steps. First step is the authentication of the connector to the director. Then you have the column from the connector to the SDN controller. Then the connector discovery by the mano. The first step is the instantiation of the new cloud based on OpenStack. And in the end, you have the so-called service orchestration of the new service chain on the connector by the orchestrator. The whole procedure takes more or less from 25 to 45 minutes. And once that your new connector is registered, you can have the possibility to use some troubleshooting tools. For example, you have the possibility to access the SSH console that can be used, of course, to have a look to the configuration of the connector and to make some troubleshooting on the machine. You can have a look to the alarms, to the events, to the summary status of the connector. You can launch the cloud dashboard, having the possibility to have a look to the embedded cloud that is located under this structure. Example, here I can have a look, for example, to the network topology that has been automatically designed in OpenStack. And what we can clearly understand is that the same service chain that is available on the connector is also available on the OpenStack dashboard. Here you can see our microtic router, the two CentOS instances, and the 4 virtual networks that have been defined in the network service template. And then the last but not the least, you have the possibility to access the service topology from the director point of view. And it is a really important tool, because from here you have the scene of the complete mapping, starting from the physical ports. For example, here you can understand that port 0.3 is the LAN port of the LANer, and 0.1 is the WAN port of the LANer, and these ports are mapped to the virtual service ports, and from the service ports to the virtual ports of the VNFs. It's really important, even the information that is in the table below, where you can find the complete mapping of all these ports, and you have some adding information that are the packets received and transmitted, and also the dropped packets. So this information can help you in making troubleshooting and locate the issue on this service chain. In my opinion, it's the most important tool for making troubleshooting that you have on this interface. So from my side, that's all. Thank you very much. I leave the podium to Marcello.
Thank you, Pasquale. Thank you very much. Very interesting indeed. So before we go for a 10 minutes coffee break, I just want to really anticipate the next slot. Basically, our workshop is about enterprise. It's about virtualization driving changes in the enterprise demand. Universal CP, what has just been described by Pasquale, and actually what Colt is going to describe much more in the next presentation, because they have adopted Universal CP as their part of their service offering, is exactly that technology that allows any enterprise to have the freedom to choose and adapt their needs according to the industry offering. What I mean is if an enterprise, for instance, is willing to adopt a firewall of brand A, and then in another year a firewall of brand B, or we're talking about SD-WAN of brand A rather than brand B. This flexibility, in a nutshell, just to make it simple, is exactly what the Universal CP is addressing. We have seen it from a very different point of view, no? From the point of view of an academic point of view, from the system integration point of view, and now really touching it as a tool, which is going to be used to do this offering. In the next slot, and I would say we can come back at 3:45 CET, I would invite Colt and Stefano to start with this presentation. So if we agree, Guido, we can stop for 10 minutes.
Yes, sure. Sorry for this small delay, 25 minutes delay. But since this is basically the last event of the day, I think we can withstand it. So please, let's get back on 3:45.
Perfect. I do have maybe even a slide for that. The coffee break. Or you have it?
I don't know if you want. I think you have it as well. But if you want, I can share mine.
Yeah. Yeah. Maybe share yours. Yeah.
Okay. Okay. See you later then.
See you later.
Che cazzo è?
I think we can start again, Marcello.
Yeah. Okay, thank you, Guido. Okay, thanks. Welcome back. And as I was anticipating, I'd like to welcome Stefano Nicastro, who's the Southern European Director of Sales Engineering at Colt Technology Services. I think I already anticipated a bit about the content of your speech, so I will leave the floor to you, Stefano. Please.
Thank you, Marcello. First of all, can you see my screen?
Yes.
Okay, perfect. Very well. Good afternoon, everyone. First of all, thank you to the host of the workshop and to Professor Guido Meyer and to you, Marcello, and all the ADVA team for giving me this opportunity to talk about this topic, which I think is very interesting. What I'm going to do today is I'm going to give you a service provider viewpoint about the changes that networks are undergoing, and specifically, I'm going to talk to you about the emerging network as a service delivery model and the era of edge computing that is just about to start in the market, specifically in the market of enterprise network services. The telecom industry is undergoing yet another wave of transformation, which we have seen a couple of times. We have heard a couple of times already today, primarily driven by the software-defined networking and the virtualization of network function. This is an historical trend. This slide is trying to capture this concept, essentially propelled by the centrality of the software and the spread of virtualization and cloud computing, which have been driven by the declining cost of hardware and the increase of computing power. And last but not least, the diffusion of new artificial intelligence applications that are greedy of computing power. So probably software-defined networking came first, or at least from a service provider viewpoint, it's something that we have been affected by earlier. And this separated the control plane from the data plane and gave birth to a new breed of on-demand network services, and also to the SD-WAN, which is something that has already, I would say, replaced the PVPN, the MPLS-based IPVPN on wide area network services for enterprise. So we have here a vertical integration of network components that belong to different layers, and that invest the backbone of the service provider mainly. This happens thanks to software capabilities that we know under the collective name of lifecycle service orchestration, which provide a coordinate management of several network domains that are responsible for delivering end-to-end connectivity services like carrier Ethernet, or again, MPLS VPNs, and that concern multiple providers' operational domains. At almost the same time, we had the virtualization of network functions, which has been introduced already, which essentially is a decoupling of the logical network function based on software from the underlying hardware. And on the right side of the slide, you also see the intelligent network, which is something that is driven by the diffusion of artificial intelligence and machine learning. This is something that is going to provide a big transformation to network services, but such a broad topic that I'm not going to touch today. So the lifecycle orchestration is probably the most important topic in the current transformation. It's a set of technology standards and products that provide orchestration and management integration over a number of network systems, management software, telecommunication IT software like BSS and OSS. The purpose of LSO is to streamline real-time automation of service lifecycle for connectivity services. But it also includes specifications for API-based automated procedures that allow the integration of network function virtualization framework. So the on-demand network service, which you can see depicted at the center of the slide, combined on-demand agility and the ubiquity of internet with the performance and security that is typical of carrier Ethernet services. Essentially, it's enable services not only between service access point residing on physical ports, such traditional Ethernet ports, but also service access points residing on virtual interface that can run in the cloud as virtual machines or virtual network functions. So on-demand services essentially provides enterprise organization with control of their connectivity. They can build dedicated point-to-point links between retail buildings, or dedicated private connections to the cloud, or dedicated public connections to the internet. And they can control everything, the provisioning, they can flex up and down the bandwidth, they can shift endpoints, add more ports, add more links through some self-service portal functionality. So this is already a revolution in the world of service provider. The lifecycle orchestration support all the steps that concern the delivery and operations. So the ordering, the orders fulfillment, performance, usage, the monitoring, the analytics, the security. So, and they don't do this just within a service provider network, but they do that also across multiple operator networks. So that's also very, very important. What does that mean? That means that if you are in the fulfillment phase of an order, then essentially the LSO take care of an order fulfillment that span across multiple service provider networks. So end to end, from the customer premises sitting on one service provider network, throughout one service provider network to the second service provider network until the other endpoint of the enterprise. So then what comes next? What comes next is that LSO is not just providing the service lifecycle service orchestration on software defined networking capabilities like on-demand services. It includes also the possibility to integrate the NFVI, the network function virtualization infrastructure. So essentially, NFV was the second main ingredient of the ongoing transformation of traditional network services. So, of course, as it was said already, it essentially established itself thanks to a better cost efficiency due to the possibility to use commercial off-the-shelf hardware like general purpose servers and storage devices to provide network functions through software virtualization techniques. These network functions are those VNFs, and they provide a number of benefits. For instance, thanks to the sharing of hardware and hardware resources, but also a number of other benefits, providing a simplified operational efficiency and a faster service innovation, reduction of power usage. So a number of things that are available. The fundamental building blocks of the network function virtualization framework is the NFV management and orchestration functionality, which is an architectural framework that can coordinate network resources for cloud-based applications and the lifecycle management of VNFs and network services. This slide is trying to show this. So if software-defined networking is, as we say, decoupling the data plane from the control plane, and the network function virtualization is decoupling the network function from the hardware, both these things combined make the network as a service principle happen. So network as a service, you can think of network as a service as the analogous to cloud-based services, such as infrastructure as a service, where users can dynamically create, modify, change compute and storage resources. So in this is not dissimilar from the infrastructure as a service. It delivers an agile framework that streamlines and automates service lifecycle end-to-end for a complete network solution that includes connectivity and NVFs. So LSO, a lifecycle orchestration, can combine the two words, the SDN and the NFV, and it does so through some set of North-South API that can integrate BSS OSS systems with a Mano system. And that is what Colt is looking at and is actually started to do already, thanks to the alliance with ADVA and their universal CPE. So moving on, the SDN and FV have impacted the carrier networks on multiple levels, backbone levels, backbone edge, and customer edge, essentially network edge and customer edge. So the NFV has introduced a number of network service features at the network edge. Nowadays, common to have centralized gateways sitting on the backbone. They provide breakout internet connections to users of enterprise networks or having a secure gateway to the web or cloud gateway. So these are all centralized gateways where you easily find implementation via network function virtualization. But the customer edge is where much more innovation is happening. With over 27,000 buildings that Colt connects directly on its own fiber network, Colt is set to develop further our portfolio strategy on the customer edge more than on the backbone edge. Now, traditional CPE consists of So essentially you have a traditional CPE where you have a number of network functions that are running on a physical device. But this provides a number of limitations and bottlenecks to the model, essentially due to the cost of the hardware, but also the resilience, as you cannot rely on VNFs that can sit on multiple locations. Now, essentially, in a UCP concept, you can overcome all these limitations because you can have multiple network functions consolidated using a software-based virtual network functions that run on top of a UCP appliance. So VNFs may reside inside an on-site hardware device, regardless of the location. It can be enterprise data center, can be the cloud, can be a retail building. So VNFs can also be distributed between universal CPE and the cloud. And when they are combined with zero-touch provisioning, then where the UCP auto-installs at the boot, then both the businesses and the service provider can simplify all the operational cycle. So Colt has adopted the universal CPE a couple of years ago as a standard way to deploy SD-WAN. Essentially, what we do is very simple. Since last year, we have SD-WAN that run on top of customer customer premises as a VNF, and we use ADVA UCP to run also a number of other VNFs on UCP, like we have next generation firewalls from some vendors, as well one optimization appliance, and soon we will also add other firewalls vendors, also virtual router functionality to the list. But this is just the starting line, as we have plans to extend the number of VNF vendors even further. So this year and next year, we are going to go beyond that and to use the power of universal CPE and the network as a service delivery model to build a new breed of products under the collective name of Colt Edge. So with Colt Edge, we will move from a provider of connectivity and managed network function to a provider of network and infrastructure as a service platform. With the adoption of universal CPE to support our network products, traditional network products, we have already made our first step. Now, with the Colt Edge, we will develop a fully fledged edge computing proposition to service customers. Edge, in fact, is the next step in the evolution from universal CPE to a micro cloud or edge infrastructure as a service. As you can see in this slide, the edge infrastructure as a service is different from all what we have seen so far. It's different from anything service provider have been doing so far. It adds to the software-defined networking and network function virtualization framework as it goes beyond an LSO environment that where only network functions and connectivity are concerned. We now have a true computing environment where an hypervisor is there to manage the computing resources in agreement with the work demand of the customer, similar to what happens in infrastructures as a service cloud delivery model. So Colt will act as an edge platform provider, selling tenant space on the edge to customers and to partners that will have to be consumed in conjunction with connectivity and managed network services, because at the very core of our business is still that of a network service provider. So we will allocate a tenant space, essentially a logical slice of the computing and storage capacity deployed at the edge. So that means a customer will have the possibility to manage CPU, RAM, and storage resources that will be provided in logical slice. And instead of having a free-form model, we will build a service catalog with service profile that will be defined. So Colt will be the edge infrastructure provider. Will also own its tenant space wherever the edge capacity is deployed, so that it can host any VNFs as part of managed network service sold to the customer. So customers will be the edge consumers that will procure tenant space from Colt to host their application. In some cases, customers may grant access to their tenancy to their own authorized third parties like partners, or Colt can do that and build a combined joint value proposition to address enterprise market requirements. So there is still a distance to walk, of course. Multiple elements need to be in place. There is no standard yet, although a number of standardization bodies are working on some frameworks, multi-access edge computing, or there is also the Linux Foundation working on this LF Edge. And then there are, of course, big players in the market like Amazon and Microsoft Azure. They have plans to build their own edge computing solutions that will extend the capabilities from their cloud into the enterprise premises. Service provider like us need to connect the dots to build the missing picture and to provide enterprise with edge computing family of services. And this will have to connect under a common lifecycle orchestration framework, so that we will provide a seamless experience and an enterprise-grade services. So now the idea behind edge computing essentially is to push the computing and the storage capabilities closer to the end consumer. If you think about this, this is not entirely a new thing, because the origin of edge computing dates back to the time of content delivery networks that were created in the 90s, and they are still around, to serve web and video content from edge servers. And so it's not entirely a new thing, but it's taking definitely a new momentum. So then the idea is to move computing power closer to end customer. This is due to the belief that for some use cases, processing and storage in centralized cloud are not good for customer experience. So the major challenges in delivering a real best-in-class end customer experience using transaction-level centralized data processing and storage are latency and throughput requirements of applications that requires immersive user experience and IoT. So the capability deployed at the edge is going to complement that capability. So essentially, edge computing is going to provide a distributed computing environment, and that will also provide a solution to a number of applications that are artificial intelligence powered. Artificial intelligence is very demanding in terms of computing resources. So let's have a look at a number of use cases we have seen. So the first one is use cases that concern enterprise in general. Essentially, we are going to provide telco VNF in a UCP model combined with a bring your own application capability. Essentially, this is going to extend system integration and proprietary application on customer premises. So there are going to be a tenancy managed by the operator, with the operator choosing virtual network function, which the customer will be responsible for licensing. And there is going to be a tenancy where enterprise can have any type of application running, provided that application is given enough computing and memory resources to work. So this is open to a number of applications. Like an example, this is an example for system integrators where you can use universal CPE with multi-tenancy and edge computing capability for smart buildings. So where code provides edge space, code provides the connectivity, and the system integrator use their tenancy to install device, sensor, and specific application for smart building automation. And then the connectivity is used also to connect to the cloud any IoT device for specific IoT computing. Other use case that we are closely looking at concerns financial services and capital markets, where we will use edge computing for application hosting. That will essentially provide a close to the customer application gateway for financial applications, and also provide computing power for modeling algorithms that are increasingly used for any type of trading, like I'm thinking of trading applications. So there are a number of users. Financial service firms will have reduced hardware consistency. They will have a better customer experience, low latency towards the computing power that is going to sit closer to them. Then Colt Edge is also going to provide solutions to a number of communication service providers, where those communication service provider buys some edge space. We do provide the network appliance and the connectivity, and they manage the VNF life cycle entirely. So that is another of the application. This is more on the side of other carriers more than enterprise, and also on the side of cloud service providers.
Just Stefano, as a quick note, we are 5 minutes, let's say, beyond time. Just
okay, I'm over. This I think I can skip. Is just a recap of what I've just said about the tenancy and the multi-tenancy. The value proposition, I think also I can skip, is essentially what we have in terms of a combined effort, a combined value between Colt and customers and partner. And just to close, essentially, edge computing framework is something that is coming out of universal CPE and is going to provide a faster experience in all the cycle of the service, of the network as a service experience. So from ordering to order fulfillment, provisioning and configuration, and also in life, because customers will be given a comprehensive set of functionality where they can hands-on operate on the solution. And that is all for me. Sorry for being some minutes late.
Thank you so much, Stefano. Very, very interesting. And for the audience, of course, we will make available all the content. Okay, so we change, let's say, perspective once again, and now we go actually more into the topic of how to operate. You know, we get even more deeper in how to operate a network. We will be starting with Carlo Cafasso, Head of Operation and Maintenance and Telecommunication at ATM. So he will dig a little bit deeper into how to operate a mission-critical network like the one of ATM, talking about transportation. So I will leave it to you, the floor, Carlo, and I see already your presentation. So please go ahead. Welcome in.
Thank you, Marcello. Can you see my presentation? Yeah, I think so.
Yes, indeed.
Okay. I'm Carlo Cafasso. I am in charge of the maintenance of the telecommunication systems of my company, ATM, that is an urban transport company. So it's in charge of the operation and maintenance of the network service of the city of Milan. Just a few numbers to have an idea of the company size. We have almost 10,000 employees, 1 billion revenues almost, and 2.5 million people living in the area of Milan. We operate metro lines. It's 5 lines with more than 100 stations. We operate tramway, trolleybus, and buses and electric buses as well. We have a plan to switch all the buses to electric buses to 2013. And I started with an example of what network reliability means to us. We have signaling systems on line 1 that is completely rely on an AP network. Here is a very efficient systems with an headway of 2 minutes, so 120 seconds. That means that every 2 minutes there is a train waiting to depart. And for the history of Milan, in the north outskirts of the city, they are the most populated area. So there are a lot of people coming to Seston and try to reach the city center. So try to figure out, we have very big train, is a Navy rail actually. So we have very big trains. On each train has a capacity of more than 1,000 passengers. So just 10 minutes of unavailability of the AP networks means 6,000 people waiting in the station for the next train. I want to figure out what that means in terms of safety. So how we operate, we have basically 3 operational control center. One is the security OCC that is in charge of the security of the assets and the passengers. Ground OCC, they control the fleets, the surface fleets, so tramways, buses, trolleybuses, and the underground operational control centers. So the security OCC use video surveillance. So there are cameras in the stations, buses, and depots. They use communication systems, Tetra network, emergency line to speak with the emergency number, and they receive alarms from the station for intrusion detection and from the depots and the access control. Then we have the ground OCC. They are in charge of the regularity of the service, so they know the position of the buses that are with the GPS location, and they can communicate with the vehicles with the Tetra network. They have some video surveillance as well. There are cameras in the cities and in the depots, and they use SCADA systems to control the electrification of the lines for the trolleybus and for the tramways. And then there are the most complicated OCC, that is the underground OCC. They use communication of various types of communication. They use TETRA to speak with the train driver, emergency line. There are sound-powered telephones in the tunnels for emergency reason. There are public announcements. They receive cameras of the stations and the depots as well. There are some projects of video analysis. Basically, we control via video analysis if a passenger goes in the tunnels from the platform, and we have about 3,000 cameras in the stations. We have SCADA systems in order to control the electrification of the lines and of the system of the station, like lifts, escalator, and there are emergency buttons in order to interrupt immediately the electrification of the lines if something happens. Then there are traffic management. There are two systems, automatic train systems, that is not safety routing of the trains, and there is the signaling systems, that is the safety systems that avoid collision of the trains. So this is our world. There are information technologies that in our company that is in charge of the websites, social networks, payment service, travel planning. Then there are operational technologies, CCTV, communication, SCADA. And then there are the essential functions, safety functions that are inside, for example, the signaling systems. So those are the network we operate. We have a TETRA network, as I said before, almost 100 radio base stations around the city. Most of them are in the stations. Then we use 3G, 4G public networks for those services that needs more throughput. The TETRA network, it's a very basic network. It only offers 7 kilobits per second throughput for data. So for everything for the service that doesn't need a really efficient reliability, we use 3G, 4G public networks. But for all those networks, TETRA and 3G, for the radio networks, there are a lot of talking to switching to 5G in the next years. We are not the only one that use TETRA. All the urban transport company in Europe use TETRA. That it's a quite old telecommunication network. But there are a lot of talking about switching to 5G in the next future. We still operate legacy networks, PDH and SDH for the legacy systems. The metro lines are quite old, and some systems had a very long life cycle, so we still operate in them. And for all the new systems and for the new lines, we operate IP networks for all the operational technologies. So basically, the IP networks we can divide in three. There are networks with different requirements. There are payment service that used for the barriers, space machine, payment service. There are operational technologies, as I already spoke about, CCTV, SCADA, passenger information systems, and the signaling systems for the communication between the train and the ground. So basically, operational networks are routed networks. We do have one optic fiber cables for each side of the rail. So basically, there is a core center positioned in the control center, and there are 2 or 4 switches in each station, and there are 1 or more 2 or more rings that connect the station with the control center. And and then there are the signaling network that is designed quite differently. Usually those are a completely independent network. They call them red and blue. So the redundancy is in charge of the device in the train and in the center that usually is SIL4. SIL4 means that is a high system safety integrity level. So those components are safety related, and they have and they are in charge of choose the right way for traffic communication. The CBT system, that is the communication-based train control, that is a signaling system very efficient, as a continuous communication between the train and the truck. That means that the connection loss of just 3 seconds causes an emergency brake. So here are the key requirements of our networks. We have to deal with a lot of regulation. I write something here. We have to deal with the availability, resilience, and maintainability. There is a standard in a railway application. There is the 5126. We have requirements of system availability, usually of 99.995%. And to reach those numbers, we have preventive maintenance, each 24-hour on-call maintenance, and full redundancy of the systems. And we are planning to build a disaster recovery site in order to increase the resilience of our systems. Safety is something very important to us. There are a lot of regulation based practically on a management system. So you have to evaluate the risk and the hazard of the systems in terms of the transport systems, and you have to deal with each risk and hazard and trying to define the right way to deal with it. But basically, safety is we deal safety on the fact that once you install systems, every change has to be precisely analyzed. So we have to deal with privacy. We have video and audio recordings. We know where passengers are. So and we detain passenger personal data. So privacy is something very important. There is the new GDPR European regulation. So we have a secure information security management system based on the 27001. That is based even in this case on a risk management approach. We have obsolescence issues. As I said before, we have to operate long life cycle systems. The signaling systems has a life cycle of 30 years, while operational technology systems usually has a life cycle of 15 years. So, and they use they are increasing the utilization of IT components. So that has really short life cycles, and this is a problem for us. Cybersecurity is something that is becoming increasingly more important. There are new regulation in Europe that is called the NIS. We have European standards, the 62443, and there are railway standards as well. Basically, even in this case, we have to perform cybersecurity management systems. So risk management and risk evaluation, and we have to plan to reduce the risk based on cybersecurity. The problem that we have with cybersecurity is that we are operating obsolete components, and it's something that we cannot avoid completely. We have just to deal with the obsolescence, and there are patch issues. A few years ago, with the WannaCry epidemic, we immediately acted and decided to patch all the systems against the new vulnerability. And it takes to us 6 months to update all those systems. So patching is really an issue in our systems. So the best way to deal with cybersecurity is the network segregation of those components. So particularly operational components should be totally segregated by IT environments. And there is another level or segregation for safety related application. So network virtualization, we are now planning to look at network virtualization. We are a urban transport company, so we are the very last list in the market that are going to change. But we think there are elements that will give us big value about network virtualization. So first of all, cybersecurity, as I said before, network segregation is something that really is important for us. And the maintainability. At the moment, we have more than 700 switches. We have a lot of firewalls, and it happens more than once that a human error produces a failure of the systems. And secondly, the necessity of the vendor lock-in, because we have a public company, and we have to perform tenders in order to buy our systems, and so we have switches of different vendors, and we have to operate them, and the numbers of protocols of those vendors are really high. So we need an easier way to deal with those protocols. And that's it. Thank you very much for listening.
Thank you, Carlo. Thank you. Perfect on time. Thanks a lot. So, I mean, we are getting closer to the end, but we have a very, very interesting last presentation, actually from Open Fiber, from Danilo Noschese, who's a network automation engineer. I mean, for the people in Italy, we all know very well Open Fiber. Open Fiber has been, I would say, a disruptive initiative and investment fostering really the European Commission Gigabit Society objective based on a pure fiber FTTH topology. Has been really, I would say, something new. It's a kind of fresh air, let's say, in our context. And on the contrary to ATM, as an enterprise, we're dealing with a lot of, say, legacy. Obviously, Open Fiber has the possibility to be a greenfield player, so to use already, let's say, the last technologies. And I will leave now Danilo just to share with us their experience, also about their investment in the service automation platform. I don't say more words. I just leave it to you for the last 20 minutes. And I know I see Guido. Do you want to say something?
Just I would like to make a short address to the attendees. While the last speaker is presenting, please elaborate your questions and put them on the chat, because after that, even if we are a little bit late, we will have the final question and answer time. So please ask questions.
Well done.
Okay.
Okay, Danilo.
Okay. Can I share my screen?
Have you been made as a presenter? Yeah.
Yes.
Yeah.
Yes,
Okay.
yes.
Here we go.
Just a second. Okay. Good evening to all. Just a second. Okay. I am Danilo Noschese. I have been working in Open Fiber from about 4 years. I work in the technology engineering department. And inside the team called Service Layer, I have the role of network automation and virtualization engineer. The topics of my short presentation are about Open Fiber Company, a brief description of the Open Fiber Company, 10 minutes long and maybe even less. I don't want to bore you. There are several slides, but I will scroll them very quickly. I want only to explain what Open Fiber does in order to allow you understanding what are our business, our commercial interests, and so what are our technical solutions, at the reason of our choices about the technologies. After that, we can talk about the technological aspect. Basically, I decided to talk about 2 topics, service automation and Edge Cloud. I will describe our experience in order to have a comparison. Okay, the reason why Open Fiber was created is to build high-speed fiber optic electronic communication network, ultra-wideband public and nationwide network, in a context where the European Commission's target is to create a true gigabit society. The strategies at the indication of the European Commission for 2025 are 1 gigabit in 100% of railway stations, airport, business, and the main public administrations, and 100 megabit per second for 100% of European households, including rural households, with an option to upgrade up to 1 gigabit. Open Fiber is a company born almost 5 years ago, operating only in the wholesale market. This is very important. Open Fiber work only in wholesale market and offer access to all interested market operator. I mean, the final user that want to do an internet subscription can do it with the market operator and not with Open Fiber. The customer of Open Fiber are the service provider. Okay. About Open Fiber, I want only to add the information that is a company jointly owned by Enel and the CDP. So the shareholders of Open Fiber are therefore a very important investment institute, the CDP, and probably the biggest energy company in Italy, the Enel. Okay, this is the network created from Open Fiber, an ultra high-speed network created in fiber to the home mode. The interconnection from the power plant to the customer home is made using optical fiber. The optical fiber is a cable in silica where transmit light over longer distances and at higher bandwidths. This enables the network to achieve the maximum performance with a speed of up to 8 gigabit per second. And that this is a technology future-proof. This is a future-proof network capable of supporting all the potential of the new technology set to develop over the next few years. In this slide, I want only to show the evolution over time of the cabling technology. Initially, the connection between the end user and the operator's infrastructure was all in copper. Then there was a second phase where the interconnection between the operator's network and the user home was mixed. The fiber optic cable is in place from the operator infrastructure at a distribution point in Italy, a sort of box, commonly called cabinet, a roadside cabinet, located usually a few hundred meters from the houses. The last phase is called FTTH, connection only in optical fiber. These are the technical features. I want to highlight above all the energy savings. a fiber access network would enable for the same number of connected customers greater energy saving compared to a copper access network, with benefits for the environment and much faster return on investment. We have also, with this topology network, greater reliability. The fiber connections are less subject to breaks in service and technical problems than copper. As future-proof, as I said, preview fiber optics is the only future-proof solution with a transmission capacity that can reach up to 40 gigabit per second. And we have also higher performance and more efficiency. There are several benefits for several areas, for people, smart cities, and company. Regarding the advantages of a very good performing network, I want to mention above all the distance learning and the home working, subject of great topicality and interest in this situation where there is a pandemic. But of course, we can have many other benefits. In this slide, there is a long list, for example, e-commerce, Internet of Things, recharging electric vehicles inside the smart city. This is summary, the summary slide. In addition, I just highlight a curiosity. The work to create an infrastructure like Open Fiber should be able to increase the gross domestic product of Italy in the next year, the GDP, the PIL in Italian. This is very important for the Italian economic aspect. This is a very important item. The project Open Fiber is divided in two areas, cluster A-B for the large cities and the cluster C&D for the small center. The Open Fiber project involves the whole of Italy with no distinction between large cities and the small center. Open Fiber works making property investment in the cities and the most urbanized area, the cluster A-B, with our investment. But for the small center, the rural areas, Open Fiber builds a public network using the tools and the resources defined by Infratel. Infratel is an in-house company of the Ministry of Economic Development. It's the infrastructure and the telecommunication for Italy. So with Open Fiber, we can cover all the needs. In addition, I can say that in the zone where it's impossible to dig into the ground and to place the fiber, because, for example, of the presence of the mountain and the hills, Open Fiber will be able to use other solution, wireless solution, or using a session radio-based or terminal session. I can skip this slide. I want only to say that behind Open Fiber, there are several commercial banks with a 7 years finance agreement. Okay, these slides are not so up-to-date, but anyway, at the end of the 2018, we involved almost 300 Italian municipalities and almost 10 million property units. And the infrastructure is completed in Turin, Milan, Bologna, Perugia, Catania. Very interesting is that in January 2018, Open Fiber signed an agreement with Acea. Acea is a very important energy company in Rome. Probably we want to take advantage of the infrastructure of the Acea in Rome, using, for example, the water pipes to spread out the optical fiber. Open Fiber in cluster C&D. To Open Fiber were assigned all the Infratel tenders for the construction and management of the ultra-wideband public network, also in rural cities and small cities. This involves about 8,000 municipalities and almost all region, 19 on 20, and involved over 40 million citizens and almost 10 million property units, and also over 500,000 company headquarters. The regions Calabria, Puglia, and Sardinia were involved in the 30 infratil tender. The tender involves about 1,000 small city municipalities. This is the last slide about the presentation of Open Fiber. Open Fiber is not a telco mobile, is a fixed company, telco company, and in the wholesale market. But anyway, in partnership with Wind3, launched an experiment regarding the 5G technology in the cities of Prato and L'Aquila. The project terminated last year, as I made to lay the foundations for the construction of a smart city. In the specific, the benefit from innovative services in various fields, including health, mobility, security, emergency prevention, and management. I want to specify that, of course, I want to remember that Open Fiber is not a telco mobile company, but with this project is being demonstrated that the 5G mobile combined with a fiber core network, a fiber backhauling network, improve the efficiency, for example, of a smart city. Finally, we can start with the technicality. Okay, initial consideration. Above all, for service automation and virtualization. In Open Fiber, the visualization currently is used in the data center server farm, and that it is based on KVM. On this platform, we have the standard application for a data center, web services, database, domain name services, authentication server, element manager, orchestration manager, and so on. Installed in a Unix virtual machine standard, Red Hat Linux or SUSE Linux. And we are using also public cloud in Amazon Web Service, for example. So we have a mixed situation. But the focus of our area is the service automation, because in order to reduce the time to market and to improve the network efficiency, Open Fiber invests a lot of resources in terms of people and money in service automation area. I want to remember that the transport network currently in Open Fiber is a physical network, and above all is VDM based, is an optical network. But anyway, it could be possible to take advantage of the widespread presence of the Open Fiber POPs, even in small cities. The POPs are the point of presence where there are the network devices of Open Fiber. To create, for example, an infrastructure of edge computing for our customer. For example, we can provide infrastructure as a service like virtual access servers, a virtual router. For example, I imagine that a telco company want to outsource their infrastructure and can ask us to provide virtual access server, virtual router. At the moment, we are still looking also for business opportunity for the most interesting and useful WNF required by the market. For example, we focus at about two software as a services, the TCP, the caching and the TCP optimization. We asked the support to a system integrator of our, and we asked the support also to three leader of innovation and network in America. So we are doing a continuous scouting in Open Fiber for NFVS and SDN solution regarding the technical aspect, but above all regarding the business aspect. Okay, this is the high-level architecture of Open Fiber. In this picture is illustrated in high level our network. We have the end user connected to the collection pot behind a device called the OLT. The OLT is a sort of switch, a sort of access devices connected to the edge router or to connect a VDM device. From here start the network the transport network, and we can reach the infrastructure of our OLO. So essentially, basically, OpenFiber sells two services. One is the pre-provisioning service. I mean the service that transports the traffic from a small or peripheral city to the network of the OLO, usually collocated in a large city. For example, we can have the user in a small cities in Sicily, and we have to transport the traffic to the network of the OLO. And the network of the OLO usually is in Milan, so we have to pass all the Italy. This is the first service that provide OpenFiber. The second service is the end user activation. I mean the user provisioning, the user authorization, or if you prefer, the subscriber activation. Configuring the appropriate parameters and the correct network configuration. Of course, the situation is much more complicated. This is a network path in detail. We have the user, the OF domain service require that the user are connected to the OLT. The OLT are connected, this is the access layer, and could be compound or by GPON OLT or solution wireless. After that, we have the transport in optical layer. We have a sort of chain to transport the traffic from the starting point, a small city, to the provincial capital, for example. From the provincial capital, start a ring, an optical ring, to connect to the regional capital. From the regional capital, start with the standard IP devices for the standard routers, start the MPLS domain, so we can reach the OLO network. For example, we can start to a little city from Lazio region, and we reach Rome, and from Rome start the MPLS pseudo wire to connect to Naples or to Milan, for example. And inside the network infrastructure, start the connection to the internet. You can imagine that to implement this service for 3 layer and 6 vendor is very complicated for a system administrator. So the manual activity, the manual configuration are very complicated. For this scope, for this reason, we implemented 2 use cases in network automation. I said before, we have the core path provisioning, the configuration in zero-touch provisioning. I mean, without any manual configuration from the OLT to the delivery kit. And the second one is the access path provisioning, the subscriber activation, with the appropriate parameter for the bandwidth and for the network. To do this, we built a network automation platform compound by 7 management systems, 3 environments, testing, pre-production, and production, 15 virtual machines, and 20 physical servers. This is the hardware component. And with this hardware component, currently we are able to configure almost 900 devices. About today, until today, we configured in zero-touch provisioning about 8,000 physical paths, and our orchestrator calculated automatically 6,000 logical resources. This is our logical platform. I wanted to explain the flow. We have the IT systems. The IT system received the commercial order from the customer OLO. our service provider. The order manager, that is the IT system, at this point can contact our orchestrator with the standard MBI protocol. We are using the REST protocol with a JSON file. Order manager pass the commercial parameter to our orchestrator. Our orchestrator at this point can configure the transport network. At this point, our orchestrator can use a different option. For example, can configure TOLT using SSH protocol. So orchestrator can access directly to TOLT and can send the correct command to implement the configuration. Or, for example, for transport devices, we are using the controllers. So the orchestrator using a standard protocol like REST-conf or NetConf, contact the controller to request the configuration in the transport network. Our orchestrator acts also as management orchestrator for the edge cloud. At the moment, I will speak about our edge cloud after. In this moment, we have only a sort of a showroom. We have only a proof of concept. We don't have edge cloud in real network. And at the end, to correlate all events, we configured our element manager to send the alert and the traps to a central assurance. We have a fault management centralized where we can do a correlation of the events of the alarms. This slide explains our interfaces. In northbound interface, we use the REST-conf protocol, the REST protocol. In southbound interface, the orchestrator can contact the domain controller using this API and this protocol. SOAP with XML to configure a section of the VDM layer. REST-conf with the JSON file to configure the area wireless IP and an area of the VDM. Instead, we use the SSH with customized network driver to implement the configuration inside the TOLT. I want to specify that when Open Fiber choose a technology, a device network, is extremely rewarding supporting standard protocol. So we prefer that the controller of the device is supporting NetConf or REST-conf protocol. And the orchestrator use a central SRI. For SRI, we indicate service resource inventory, where we put all the information of the connection extra domain. I mean, for example, a connection between an OLT with a router or an LT with a VDM. And this inventory can instead take the information about the connection intra-domain directly to the, using the domain controller. For example, the connection inside the IP layer are listed inside the domain controller. Next step, Open Fiber currently is receiving 1,000 service requests a day. It could be generated bottleneck. So our orchestrator could get worse in terms of response time, and therefore we want to improve our architecture, building a geographical solution. For example, our idea is to maintain high performance installing a new central orchestrator and use it only to dispatch the request and to spread in different sub-orchestrator, per example, in two modes. One mode is in geographical mode. For example, we could use an orchestrator to configure the devices in North Italy, and we could use another orchestrator to configure the devices only in the South Italy. Or we can use orchestrator divided for technology. For example, we can use an orchestrator for access layer and orchestrator for transport layer. With this solution, we hope to improve the throughput, decrease the response time, increase the scalability and the reliability. About the service automation, I completed my description. Now we can speak about our solution for the edge cloud. At the moment, we are doing only scouting in OpenFiber. For example, we imagine to have a slow download, and we want to know what happens if we move about the quality of experience. What happens if we move the content near to the user. To test this, we created this infrastructure. We asked the support to a system integrator of ours. We set up a standard configuration. We use an infrastructure with a rack service, with a rack server. If I remember well, in a hyperconvergent mode configuration. And we installed two virtualization layers, VMware KVM, based on the requirement of the virtual machine, because our scope is to test 4 different virtual machines. 2 for the infrastructure as a service, a virtual access server, a virtual router, installed on VMware. And on KVM, we installed the transparent caching to move the contact near to the user, and another virtual machine and other virtual function for the TCP accelerator. TCP accelerator from my vendor, American vendor.
Sorry, Danilo, just don't want to interrupt. Just for you to know, we are 10 minutes beyond the time. Just for you to know for the further slides.
Okay. I almost terminated. Sorry. Okay. I skip the. I go faster. Sorry. In this. We tested this solution where we put in Edge Cloud. In a pop of edge, sorry, our infrastructure. Inside this infrastructure, we installed the virtual access server, the virtual router, the VNF for the cache, and the VNF for the accelerator. We divided the POC in 2 phases. One phase is for the functional test, and the second phase, the most important, with the realistic test using 2 agents, and we created we generated 2 traffic flow. One, the traffic from the first agent pass the standard path. The second agent pass through our edge cloud computing. So we had the possibility to do a comparison about the transfer time. We did 3 test types: file download, web page viewing, and video streaming, using the protocol most important, HTTP, FTP, and HTTPS. As you see, we had a good result, huge improvement when the traffic in file download, when the traffic is not, of course, is not encrypted. When the traffic was encrypted, we tested only the TCP acceleration, and we had only slight improvement. The combination of caching and the TCP acceleration is very difficult to see, because the transparent caching operates only on element bigger than 5000 bytes. Therefore, the improvement in performance is mostly due to caching if the web page contains big elements. And about the video streaming, that now, as you know, is only in cipher traffic. We cannot use the caching, because to use the caching we have to have the cipher keys to encrypt and decrypt traffic. So we would do an agreement with the owner of the video, for example, Amazon or YouTube. So at the moment, our impression is that we can use the virtual function only for a few of scenarios, but not for all traffic. So we want to continue with our scouting. I terminated.
Thank you, Danilo. Thank you very much. Sorry for having pushed you a little bit. Was indeed very interesting. So now we are at the end, actually, of our workshop. A list of all the speakers, and a big thank you to everybody contributing so far. So according to the agenda, we have a Q&A session. Now, I'm not seeing too many questions in the chat room, but I would basically pass the word to my two other co-chairs, so they can work a bit. Guido and Davide Botto. Guido might have a couple of questions, and maybe Davide will leave it then to you just to explain what we could also do in terms of distributing maybe some questions to the audience. Guido, go ahead. I think you are on mute. Guido, you are on mute.
Thank you very much, Marcello, and I would like to thank all the speakers of the workshop. So I have a question just to break the ice to Colt. When you are explaining the LSO, when you explain the LSO, it clearly is something that gives your customer, as a service provider, gives your customer a lot of, let's say, autonomy, and also not only on the technological control of the network, but also in the choice of the service providers. As you mentioned, using, for instance, SD-WAN, the connection between different sites of the company can rely not only just on one service provider, but maybe multiple service providers. So my question is, how this is changing your business model, especially in the relation of the other service providers that may also be your competitors?
Thank you. Very good question. Yes, the software-defined networking is giving a possibility to automate all the operational cycle that concerns the interconnection with other providers. So the procurement, the billing, the monitoring, and so on. So actually, currently in our business, we always have to use circuits provided by our competitors to build wide area network solutions for our enterprise customers. Because if you have a location that is not sitting on our fiber network or enough close to our fiber network, then we have to build the famous last mile, and we build it through of our partners' networks, which are also our competitors. So essentially, this is already like this. With the software-defined networking, with all the life cycle orchestration capabilities, we are going to automate this cycle. It's not a change in the business, it's a simplification of the all operational cycle.
Thank you very much, Stefano. I have also a question to Carlo Cafasso of ATM. My question is like this: since you mentioned that ATM is also exploring the possibilities that are provided by NFV to extend its network and also making it more robust. For instance, adding redundancy in order to ensure service continuity. My question is, are you already finding some companies that are responding to your needs and that can be candidates as suppliers of future VNFs for that are of course compliant with your extreme, let's say, extreme requirements?
Yeah, no, at the moment we are in really beginning of the process. We have just renovated the hardware of the stations, and we are planning to better understand what we can have from the new technology. But it's we are really at the beginning, and we have to understand how it is possible to deal with this new technology, because we have to for everything we buy, we have to make a tender. So for at the moment we are not in the, we don't have the knowledge even to define exactly which could be the requirements of the tenders.
Okay. So thank you very much. Any other question from the chat? I don't see any.
I would maybe one, and I'm sorry to go back to Stefano from Colt, but I think it's an opportunity to have an international, a pan-European carrier like Colt, just to benchmark maybe the level of and experience, no, the level of adoption. If we're talking about universal CPE, if we're talking about the service you just described, can you briefly, let's say, describe what is the adoption level today, you know, Italy versus the rest of Europe, or if you see specific market segment or specific geography that are the so-called early adapters here?
No, I think we are in an early phase across Europe. Is not so different from Italy, from my viewpoint, from what I can see concerning solutions we are proposing to customers sitting elsewhere. It's maybe a bit ahead in the United States, but in Europe is early stage, and that's what makes all this so exciting, because it's like we are seeing the convergence of IT delivery models and what has been the traditional network service industry happening. So it's unfolding in front of us at the moment.
Okay, very promising. Thank you, Stefano. I will leave it then to Davide, the floor.
I've a question to Stefano too, namely which have been, let's say, the most, let's say, daring things that you have done while implementing these, namely if you have found some big problem in doing this virtualization path, or if everything has been planned and made in the simplest way as possible.
Well, it's a road with several bumps, actually. Nothing comes easy, especially because there are two worlds meeting, the IT worlds and the network worlds, and many challenges happen at the interface. So when you have to, to build the interface, well, I can mention some example of some challenges we have seen, and it concerns the integration of some of the legacy. The integration of the legacy we see is always challenging. When you have I'm more thinking of it from a customer viewpoint, Davide, rather than just the service provider backbone, because everything that happens in the backbone and in the service provider infrastructure is normally quite easily addressed. When you have a customer, you have also expectations you have to fulfill. So what happens there is that the legacy, so the customer is using services in some way, and migrating customers from the way they are working today to the new environment sometimes create some friction. Like if they are already using, firewalling functions in a traditional way, and now the firewalling functions are becoming a virtual network function, and then not everything works exactly the same fashion. You have to do some integration.
Thank you very much. A question to Danilo of Open Fiber. Just as my question is, just as you are managing so many nodes, and let's say you have an EV load on your machines and your devices. So the idea is, the question is, how have you measured the performances of your systems to be able to guarantee a good working time to have the deployment of and the result, obviously, in your network? Did you have made some performance assessment, and if yes, which type of assessment engine you have set up?
Good point. I don't manage personally this item. There is a colleague of mine that follow the stream of the performance management. If I remember well, there is a solution from an American partner that check the status of the and the user, and also run the measure of the single devices. I don't know well I mean, if I understand well, your question is about the performance in the network, not of orchestrator system. There is a solution, but I don't know well this architecture because it's followed from another colleague.
Okay, thank you, Daniel. I have some poll, some survey that is to be, let's say, distributed. So if you agree, I can share with you or with you all these polls, and open these can be received in the polling tab that you should find. And so I kindly ask you if you can answer them, so we can have them, let's say, an overview, and for all the people attending this afternoon. I try to send them all. Please let me know if everything is working fine.
Looks fine, yeah.
And if you kindly can answer to this question. So that would be very useful to understand many things on what's happening really in the providers and university world. And this could be, let's say, a precious feedback for all of us. So I would like to leave a few minutes for this. Then I leave to Guido.
Very interesting questions, Davide.
Hoping so. Not for the post-COVID, just as it's not mine. That was by default.
I think post-COVID question was there because there will be on Thursday the second workshop that will be sponsored by Women in Engineering IEEE section. In that workshop, we'll deal with this question. So please, if you can also answer to that question.
So I think if you agree, we can start reading the result. So about the question, what do you think about the university and providers cooperation to create a new culture? We can say that the first answer, namely it's the needed step towards this direction, is, let's say, the higher result. And so it's an important point is to create and to establish this cooperation between university and the production world, let's say, the companies. Just as only through this approach we can think in growing in knowledge and growing in and shortening the time of deploying this solution, especially when it's a new technology and new solutions like the one that we are talking about. About the question, is your company introducing NFV SDN in the next year? So yes, is 78%. So and maybe 22. So we are really confident that these new technologies will arise and grow more, let's say, with a positive slope in the next year. And so this is even a good news, just as every one of us feels that the future is this one, and we have only to establish the way and of approaching this new challenge in the best way for our companies. About the third question, are your IT and networking depth separated, or are you going to use them to get more ready for network virtualization evolution? The result is yes, 67%, and no, 17%. So we have to, some company, let's say, thinks that this fusion is needed, someone else about 20%, 1/5 is not so is not of this idea, but even this, I think that it's a change that every company will live in its own proper way. So it's not said that everyone will approach the topic in the same way. About the question, is your company investing in know-how, competence assessment to be prepared for the future? The result is yes, 100%. So this is a very it's a very important question and a very important result, just as it means that all the companies that are attending this workshop are investing in culture, are investing in know-how, and so this is very, very important. I think for our country, just as an Italian, obviously, but I think for all the attendants, just as investing culture, technological and not only technological, is always a good way of investing time and resource and money. About the other question, according to your opinion, why the NFV SDN migration has not widely started broadly in your company? And so even in this we have, let's say, different results. The first 20% says lack of competencies. 40% says it's a challenge that the market is not rewarding yet. So it means that the market is not perceiving effectively which is the value of having these services delivered through an FVSDN network. 20% too much money to invest, and so this is an investment problem. 20% it's too much difficult to create a business case to make investments. Obviously, everyone is living in a particular stage of the path towards this virtualization or hybrid virtualization target, and so everyone is, let's say, living its own problems and facing with different situations that need to be managed, let's say, case by case. The last question is, are there topics you would like to go deeper in? In this case, there is 30% that is interested in NFV SDN architecture. So I think, Guido, that you have to do more courses and to have these courses more, let's say, diffused, even with some, let's say, webinar on YouTube, so everyone can, let's say, enjoy of your courses. 14% is interested in other products and services, so that's for you. 14% on Highway, 14% on Colt, 16% on polytechnical cooperation possibilities. And so, Guido, this is another point for you.
Yes,
and,
you have my email address, so please write me.
Okay, and so ATM and Open Fiber for the use case, for the rest in 14%. So I think that even the answers of this survey are really interesting, just as depicts exactly what we live in our, let's say, day-by-day activity and the talks. And so it's thank you very much, Guido. Thank you, Marcello, and thank you, obviously, to all the speakers of today's workshop. Thank you.
Thank you, Davide.
So, let me thank myself, all the speakers, and especially Davide and Marcello for the organization of this workshop. And I would like to invite all the attendees to join again DRCN tomorrow morning at 10:30 for the 10:25 for the opening session. So thank you very much, and so see you tomorrow. Have a nice evening, everybody.
Ciao, Guido. Thank you.
Grazie, ciao.
Thank you.
Ciao.
Ciao.